Hi everyone, this is Dr.Senthil, Associate Professor, Department of SNS College of Technology. Now let me see a video series on application of artificial intelligence in power system as a case study based video handled by Ms. Abhisha and Ms. Sudiksha of final year criminal. This is the course which is named as Artificial Intelligence in Electrical Engineering, which is offered to 7th semester triple students. Now let me see the DT based study.
Hello all. Now we are going to discuss a case study on the topic of AI power system for robust signal transmission. The system aims to ensure reliable data transmission from a sending end to a receiving end over a transmission line. The core innovation lies in the integration of artificial intelligence components, specifically a fault detector, expert system, fuzzy logic, and artificial neural network to enhance the system performance, particularly in handling uncertainties, fault, and environmental variations.
The block diagram consists of artificial neural network block and fuzzy logic block as a control system, where the sending end voltage and the receiving end voltage is controlled with the help of this controller block. One is your fuzzy and another one is your neural network, where all these is a soft computing technique which is acting as an expert system for this power system controller.
AI applications are cloud employed machine learning algorithm. For example, anomaly detector classifications are trained on historical data of normal and then fault system behavior. It might analyze signal strength, error rating, or a specified waveform characteristics. Environmental sensor. The function for environmental sensor is the sensor gathered data from the surrounding environment that might affect the transmission line. For example, temperature, humidity, electromagnetic interference, weather conditions. The next one is an integral with AI. The data from environmental sensor feeds into an AI component. Likely the expert systems or directly into an logical neutral networks to provide the content for fault detections and adoptions. Expert system. The expert system function is an AI programmer that emulates the decision making ability of a human expert. In this contact, they would contain a knowledgeable base of rule and fact about the transmission systems, operations, and fault diagonals. The AI applications. When a potential fault is detected by a fault detector or when unusual environmental conditions are reported by environmental sensor, the expert system would use rules to confirm the fault, identify the type of fault, such as initiate a remediate step, provide informations to an neutral networks.
As for the neural network controller, the neural network is a simplified version of biological neural system. You mean a parallel distributed processing system which is highly interconnected neuron networks. It is similar to our brain. The neuron receives electrochemical signals and transmits electrical impulses to the other neurons, which is our brain. In similar structure, the neural network operates, which acts as a controller for this power system domain.
The next one is fuzzification. The function of fuzzification is the first stage of fuzzy logic system. It converts crisp input values, that is signal strength in decibel, temperature in Celsius, into fuzzy set representing linguistic terms, example very low, moderate or high. The AI applications handle vagueness and impressions inherent in real-world data and expert knowledge. For example, signal is weak is a fuzzy concept that the fuzzification can qualify. Fuzzy rules. Function. These are if-then statement that defines the relationship between fuzzy and the fuzzy output. These are typically derived from expert knowledge or learned from data. The AI application example is if the signal is low and noise level is high, then transmission quality is poor. Fuzzy interference. The function of fuzzy interference is the core reasoning engine of fuzzy logic system. It applies the fuzzy rules to fuzzified input to determine any output. Defuzzification. Its function is the final stage of fuzzy logic system. It converts the fuzzy output back into crisp, actionable values. The AI application is to translate the abstract fuzzy reasoning into concrete action and measure that the system can use. Artificial neural network. The function of ANNs are computational models inspired by the structure and function of biological neural network. They are excellent pattern recognition, classification, and prediction. The AI application are complement to fuzzy logic or expert system. The ANN could be used for the tasks that are difficult to define with explicit rules such as predicting the future faults based on historical trends, recognizing complex patterns in signal noise, or optimizing system parameters in different environmental conditions. The learning and adaptation of ANN can are from data, allowing the system to adapt and improve from the performance over the time as more operational data become available.
Now the topic is data flow and interconnections. The sending and transmit data to and transmission line. The transmission line sends the data to and receiving end. The fault detector continuously monitors the transmission line and likely aspects of an send and receiving end of an derivations. Environmental sensor provides an external content to an system. The fault detector and environmental sensor feed information into an expert system and potential directly into an fuzzification process of an artificial neural network. The expert system can guide or inform the specific logic component. Um, this suggestions that expert the acknowledgement can refine or to be integrated with an fuzzy reasoning. The artificial neural network was receiving input from various points in the system. For example, fault detector outputs environmental sensor data, fuzzy logic outputs to learn complex relationship or perform predictive analysis. The output of defuzzifications and an artificial neural network thought that connections to and control machines shows the connections to and control machines would likely feed into and control unit to initiate corrective actions.
Now let's discuss about the challenges and considerations. Data availability. Training effective AI models require large amount of high quality data including historical fault data. Expert knowledge elucidations. Building robust expert system and fuzzy rule base require careful elucidation of knowledge from domain experts. Model system complexity. Integration multiple AI programs can increase the overall system complexity. High real-time processing. An AI component need to process data and make decisions in real time, especially for critical fault detection. Thank you.
As a conclusion part of this case study, artificial neural network helps in load forecasting in the power system sector and load forecasting, load dissemination and load distribution sites, such that the sending end power and the receiving end power may be balanced and the power shortages may be reduced if artificial intelligence comes to the picture. Thank you.